Okay, hello, hello.
Yo.
Hi there.
All right. Today we're here with Samuel Colvin, who's the creator of a Python library called Pydantic. And my understanding is Pydantic is a library that allows you to do typed validation of external data in Python. So, I mean, when I first found out about it, the first thought was, oh, it's like an ORM, but it does much more than just like validation of data from the database, right? It's really any sort of external data that comes into your system, whether it's from the database or from the network or something you scraped on the internet. You can put it into Pydantic object and then validate that it's type correct and enforce things like default values and things like that. Would you say that's right? Is there anything that you want to kind of like add or qualify there, Samuel?
Yeah, that's true. I think the two things that mean that people, I guess, that people appreciate about Pydantic is that the way that we define those types is using type hints in Python. So type hints in Python, like in TypeScript, they're kind of advisory only by default. So they're there to help humans reading it, to help documentation, to help static type analysis, but they don't do anything at runtime. So Pydantic takes them and uses them to enforce types. So you don't need to learn any new DSL to build a complex model with Pydantic. You just use normal type hints and Pydantic takes care of the validation. Then the other thing, which is kind of along the same lines, we generate a schema from that model using JSON schema. So we try and fall back or try and use default like well-defined, externally defined tools and technologies wherever possible to make it Pydantic integrate with other tools really easily. So for example, because we generate JSON schema, Retool and Swagger and OpenAPI can all, well, Retool and Swagger can generate API docs straight from an API defined with Pydantic.
Nice.
With no extra work from the developer.
That's awesome. Can you talk a little bit about like the backstory? You know, what motivated you to create it? What was kind of the state of the world that you're looking at the time you made it? And how did this thing get started?
Yeah, absolutely. I can. I'd love to say that I had some like grand vision back in 2017 of what Pydantic was going to be used for, or how it was going to work. I just had a frustration that type hints were sitting there. I could use them to annotate things, but they didn't mean anything at runtime. And so I kind of started off as an experiment in a file within a project. Could I somehow get hold of those annotations and then validate against them? And that the project grew kind of organically from there. Banged it up on PyPI and Hacker News, and it got a bit of attention on Hacker News back when I first launched it. But then it was just like, another library I'd launched that I replied to occasional issues, but it grew a lot in the background. And then Sebastian Ramirez, the developer of Fast API, came along and built Fast API, but also extended Pydantic a lot. So he did the initial implementation of JSON schema to be used with Fast API in I think 2018 initially, and that caused an increase in the usage of Pydantic. And then I was just saying before we went live, in beginning of 2021, I don't know what happened. I'd love to know, but like usage of Pydantic just took off.
That's awesome.
So we went from
Fast API is kind of like a new like modern web framework for Python, right? And so it sounds like that was your first kind of like big consumer. When you first created Pydantic, was there a particular like use case that you had in mind? Was it like database oriented or network oriented, or was it just more of like a general like, hey, like the typings are there, we should be making use of this for external data validation?
So I was using it for, it was general, but I was using it particularly for API validation. And I also used it for settings management. So we still have base settings, which basically reads environment variables and other sources like Docker secrets. That was a big part of what I thought of it as. I guess it's quite, I think a lot of people use it, but it's only, it's one of the many applications now.
Yeah, I got it. Yeah, settings validation. That rings a bell. I've definitely worked on code where you're getting stuff from settings, defined in JSON or something like that, and you just have a bunch of type checks and assertions everywhere. Yeah, cool. And so with Pydantic, it basically the way you would use it is it the way that most people use it by extending this like base model class that allows you to describe like the type that you want, and then that becomes like you just put the external data that you get instantiate it in the form of an instance of your subclass of this base model, and that does kind of like all the type checking that you need.
Yeah, exactly. That's the most common way people use it. We also integrate with data classes, which is obviously vanilla Python data class, I suppose, is it's well named. I guess a bit like a struct in a compiled language like Rust or C++. And then we'll come on to Pydantic v2, which I've been working on sooner. But Pydantic v2, we still have models, we still support data classes, etc. But there's no Pydantic model at the base of validation. We have composable validators, so you could validate a single int or a string or a list of models of data classes, any complex model with no overhead. So
interesting. Okay, so just to show that off to people real quick. So I'm just looking at the Pydantic docs here. This is the example of how you use the base model today. You basically just define your model class as a subclass of base model. Declare types on certain fields. You can also declare default values, and then you have your external data blob here, and you just instantiate an instance of your data model class with the external data, and it will do the validation for you and also set default values and things like that.
Right.
And you're saying like the next version looks a bit different than this, is more like composable things.
So this will work absolutely fine.
Okay.
But if you wanted to, for example, your root object in validation was a list of users. In Pydantic v1, you would need to create a model that had one field, which was list of users.
Right.
To do that. With Pydantic v2, the root type doesn't need to be a Pydantic model. So it could be, like I say, a list of users, but it could also be just a date time or any other single type you wanted.
Okay, very cool.
We also have support. Now we'll have full support for type dicts, which are a new type in Python, relatively new, somewhat like an interface in TypeScript. So basically defining different types in on a dictionary. So there, unlike a model, you have the concept of something missing. So you might have a field which is not required and therefore, doesn't have to be there, as opposed to is none when you haven't filled it in. So we'll have full support for type dicts, which are slightly faster, I guess, than a model, because you still have to only have to create a dictionary.
Yeah. Okay. Cool. That's awesome. Talk a little bit more about the evolution of Pydantic. So you mentioned that you created it to kind of scratch your own itch around API validation. There was an inflection point when Fast API started using it, and then after that, it sort of took off in 2021. What was your kind of interaction with the Fast API maintainer and maintainers? Did you know them beforehand, or did they kind of get in touch? What do you think made them, select Pydantic as kind of like a core piece of their framework?
So I didn't know Sebastian at all before. I've subsequently become good friends with him. I've met him and worked with him loads on stuff. I've just sent you a link to Google Looker kind of graph showing the growth of Pydantic recently, which kind of might give folks an idea of the kind of like slightly crazy growth since 2021. Yeah. But yeah, Sebastian came along, and I got 50 emails from him over a weekend as he started like working on JSON schema, and I was like, who is this guy? But yeah, his work was amazing then, and obviously Fast API is it's an incredible piece of work. It's obviously built on top of Starlit and Pydantic, but Sebastian went and looked at how the new JavaScript frameworks were being built and how they were using dependency injection, and he took all those ideas and built them into a Python web framework, which is why Fast API has been so like crazily successful. So if do you want me to open that link, or would it be easier for you to share your screen with it?
Yeah, I'll share a screen. You keep talking.
but you'll see on that, like Fast API's growth, it's not obviously used as much as Pydantic, but it's overtaken Django, which is the kind of default, the most widely used web framework was the most well-known web framework.
That's incredible. Look at that.
Yeah. So so the numbers are getting kind of crazy in terms of Pydantic, but as you say, even Fast API has overtaken Django, and like those numbers for Django are pretty big themselves. So I mean, to be clear, I mean no disrespect to Django. Django's amazing. I've used it a lot. run companies running it. It's amazing, but like I include it there just as the kind of benchmark because it's so widely known.
I wonder if so this is tracking downloads. I wonder if here I wonder if I'm going to use Sourcegraph real quick to see if it reflects in kind of like the source level stuff too, right? So sorry, select repo. So this would be like all the repositories that have fast API referenced in them, and then see if we can do like a similar one for Django. Just curious if this is okay. I need to count. All right, sorry to interrupt. Keep talking while I figure out this query.
I'm transfixed by you doing this live and trying to see what you're doing. So sorry, I stopped. Yeah, I've worked a lot with Sebastian. We've made some changes to Pydantic to support fast API. Some of the big changes coming in V2 reflect things that were problematic for Sebastian when working on fast API, but and also we're used in a bunch of other libraries. So I think something like 15 million of the 45 million downloads of Pydantic a month are through other libraries. So SQL model, which is also maintained by Sebastian, but also there are like 6 or 7 other ORMs built on top of Pydantic. There's Hugging Face and massively widely used projects like that.
Oh, that's awesome.
That are built on top of it. The guys at Explosion AI use Pydantic a lot. So their tools like, now you're testing me, but Think and others also obviously make extensive use of Pydantic. So it's widely used. It's a funny mixture because it's not one of those like component libraries that's deep down in the dependency chain and not seen. It's installed directly, but it's also a building block for a bunch of other things. So there's like Django Ninja, which builds on top of, integrates Pydantic into Django. And a bunch of like ML tools that use Pydantic mostly for like cleaning data prior to like training your model or looking at your data frame or whatever.
Okay, that's awesome. So here are kind of like the Sourcegraph queries. So disclaimer, like our open source index, it includes every GitHub repository, I think, with above 4 stars. So it's not universal. If there's repositories out there with less than 4 stars, it may not show up in the search. But I think at least according to our index, so Django still has around 41,000 repositories importing it, which makes sense because it's literally been around for like decades at this point. And but fast API is coming in hot with around 5.3 thousand imports. And
just out of interest, what's that number for Django for Pydantic? Did you run that?
Pydantic. Here, let me. Let's see, Pydantic. 6,500. Yeah.
Interesting.
So that's very cool. I mean, it kind of maps. Like you'd expect that there's just this like long tail of projects that use Django out there, many of which may no longer be under active development or maintained necessarily, just because it's existed for so long.
Absolutely. And they wouldn't be having the downloads because they wouldn't be like running CI 10 times a day like some commercial projects would be.
Exactly. But like it's pretty cool. I mean, like look at all these kind of like highly starred projects using Pydantic and Django. Like there's some cool projects here. Like I don't know what this like prefect repository is, but it's got 11,000 stars on GitHub. So seems like someone must be getting value out of this.
Yeah, Prefect, I think they're quite a big company. I don't know that much about what they do, but yeah.
Nice. Cool. Yeah, look at all these like major repositories. This is Pydantic itself. Tortoise ORM, so you're getting used in ORMs, which makes a lot of sense. Pandera.
Yeah.
Anyways, very cool. Cool. All right, so things kind of hit an inflection point in 2021. You got a lot of feedback from Fast API and other users, and that kind of motivated this complete rewrite from the ground up, Pydantic version 2. We were talking about this before we went live, you were saying that the new version of Pydantic is written almost completely in Rust. So talk a little bit more about that. Like, why did you decide to do the rewrite, and what motivated your decision to use Rust?
Yeah, it kind of started off as an experiment again. Like, could I build the like very basic kernel of a validator in Rust and make it significantly faster than Python? Obviously, the naive assumption would be, oh, well, it's Rust, so it must be way faster than Python. But obviously, we're working with Python types a great deal of the time. So it's not necessarily a no-brainer that writing relatively small components in Rust should be faster. So for example, if you need to take a generic Python object and check if it's a string and return it if it is, that's not much faster being written in Rust, because you're effectively doing the same call to the Python C code that your standard Python code would be doing. Obviously, where the speed comes in is where you create an actual string instance in Rust, and then you do the checks on like length bounds, or apply a regex on that string, etc., etc. Then it obviously becomes way faster. So it was not entirely obvious that it would be faster, but yeah, I think a mixture of the composable way we've built it with these like small individual validators that are just recursively contain references to each other, and obviously building it in Rust has made it somewhere between 5 and 50 times faster. Average seems to be about 17 times faster, which, when you think Pydantic was already reasonably fast, it was already among the fastest data validation libraries in Python. It was kind of 16 times faster than Django RESTful framework already. Not to call out Django RESTful framework in particular, but like,
wow,
it was already reasonably fast, kind of on a par with some other fast Python libraries like Atras. A bit faster than Marshmallow, which was kind of predated Pydantic a bit. So yeah, moving up that much faster is a big win. One of the things that it also allowed us to do, so when the input is JSON, we parse it directly in Rust. So it doesn't become it doesn't go JSON Python types validation back as Python types. We parse the JSON directly in Rust, and then coerce it to Python types as per the validation. That has two advantages. One, obviously, it means we're way faster because we can deal directly with those Rust types. But also, one of the things I didn't mention earlier about one of the reasons I think Pydantic is popular, although also slightly controversial, is that Pydantic errs towards coercing things. So if you submit a string of 1, 2, 3 to an integer field, we'll automatically parse it to 123 by default in Pydantic.
Interesting.
And a number of other like sensible, obvious coercions. If you supply a list to a set, for example, we'll convert the list to a set. That's great in most situations. There are times when you don't want it. And another big move in Pydantic v2 is we now have strict mode where we don't do that. That strict mode wouldn't work with JSON. So for example, if you were like, I have a strict field that's a date time, obviously JSON doesn't have a date time type. So the date time will probably be a string. In that case, strict validation would work for many things, but it would fail for that datetime field if you converted it to Python. Because we do parsing JSON directly, we can say, okay, we're in strict mode, but we know there's no datetime type in JSON, so we're going to allow a string formatted date as the input, even though we're in strict mode. So that the Rust parsing of JSON allows us to do sense of strict mode that actually works, I guess is the best way of describing it.
Got it. That makes a lot of sense. I was wondering, maybe we can show off some of the Rust bindings, because folks might be interested in seeing what invoking Python from Rust looks like. So here's kind of the source repository. We can verify that you're the #1 contributor to this library. You got you're in kind of the clear leaderboard. Only challenged by Dependabot for a number of commits.
So what you'll want to do is go to Pydantic core, so same repo, but just add -core to the end. So Pydantic, Pydantic's the internal validation library is implemented by this library, which is then a dependency of Pydantic itself. That just means the reason we do that is basically we can build, I think we build something like 60 different binaries for Pydantic. So we don't want to build those binaries in the main Python project. So Python itself becomes a pure Python. Pydantic itself becomes a pure Python project, just as one dependency, which is this library, which is then obviously compiled and available as a compiled binary for virtually every possible application
Cool. Got it.
environment.
Okay, so this file probably has a lot of Rust code.
Yeah.
Okay, yeah. So there's a lot of Rust in here. Where would is there like a Python file where it invokes like the Rust bindings? Like I'm trying to find an illustrative example of how this invocation works.
Yeah. So what you'll want is you'll want init.py. So double underscore,
right? Okay. This,
yep.
right?
Yeah.
Okay, cool.
So from there, all we do here is we're importing the types from Rust and exporting them again. So the next file you want to go to is lib.rs, which is a Rust file, which is where I guess is the root of the library from a Rust point of view.
Oh, interesting.
So this is where effectively you'll see at the bottom that we create a Python module called _Pydantic core. So that's standard in Python when you're having a compiled module that you'll give it a name underscore.
Very cool.
So if we just go back a minute, and I was just saying, yeah. So we have, and then we add a bunch of classes to that module and a couple of functions, and yeah, export that module, and there are the things that are accessible. But yeah, schema validator is probably a good place to start, because that's the base class that we use for all validation in Pydantic core. So yeah, this takes any object of which is a schema. So this is where things get slightly mind-numbing. The way that Pydantic core works, it doesn't deal with type annotations directly. We have a schema called Pydantic core schema, which you can in fact find, and maybe it'd be worth looking at, which is in a file called core_schema.py.
Is it just called Pydantic core schema?
No, it's called core_schema.
core_schema. Oh, the file name.
Yeah.
Oh, okay, sorry, I was looking for the symbol.
Yeah, so this is where we get a bit crazy. So we core_schema.py.
There we go. Yeah.
So this defines, using Python type annotations, the schema of Pydantic core. We then take that at compile time, turn it into a dictionary-based Pydantic core schema, and then we use Pydantic core itself to validate the schema that you pass to it. So that if the schema you pass is invalid, it will come back with a Pydantic validation error saying the schema you passed is invalid. So if you go to the bottom of this file, there's a massive union, which is effectively all the types that you can pass. Not there, up from that, up from that. So there we are. So core schema fundamentally is this union of like a bunch of different schemas, which, as you can imagine, define all of the common types. Some of these are standalone. For example, bool schema defines something that's bool, and it has a strict and a lax mode. In strict mode, obviously, it needs true or false. In lax mode, it will allow like common strings like the string true and the string false. But some of these more complex schemas, for example, the dict schema that you'll find in there, contains within it two schemas, which are
typed and untyped, or
no. So that you'll have the schema for keys and the schema for values, which in
okay,
turn is a core schema, right? So this is where I'm explaining the idea that like you can go as deep as you like with the schema that you build.
Okay.
So if you look in the README, if you look in readme.md, you'll see an example, an illustrative example here. So we took that schema validator that we were looking at before, and we initialized it with just this one dictionary, which in this case is a type dict schema, and it has within it 3 elements or attributes. So you can imagine this is somewhat equivalent to the model that we were looking at earlier. The first of which is a name and is of type string. Second of which is age, is of type int, and it has to be greater than 18. And the third of which is developer, and which default is well, in this case, the way we build it is we build it with a default schema, which in turn has a subschema, which is bool, and it has a default of true. So that's how we define defaults here. So you could imagine writing out one of these is going to be
Interesting.
somewhat hellish for a complex schema. So that's what
Yeah.
Pydantic version 2 does, is effectively turns type annotations into this core schema, passes it to schema validator, and you get back, in this case, the attribute, the variable v, which allows you to do validation, either of a
Interesting.
Python object, as we see here, or of JSON directly.
Okay, so underneath the hood, you're taking Python type annotations and translating it to the core schema that we saw earlier.
Yep.
Sorry, it was that
Listing.
like big union.
Yep.
And then you're passing, you're basically using schema validator classes to validate that whatever values that you want to validate fit a certain type match the schema that the user has specified. So here, this is like I guess an example of an instance that fits into that core schema. So you're validating a type dict, and then you're passing a schema for the keys and the values. And then down here, okay, then you can use that object to validate JSON objects.
Right, and then we're doing the proper
see.
validation like you would have done before, and that's like somewhat in some sense no different, other than obviously the second case where we're parsing, in this case, JSON directly, so that goes straight into Rust as bytes and is parsed byte for byte in Rust. And then just to make it even more complicated, we do the whole thing again, the other side, with schema serializers, where we can customize serialization.
Okay, so what part is in Rust? Because there's two parts here. The one is translating from Python type annotations into the core schema, and then the other one is enforcing the core schema through validation and also serialization. Are they both in Rust or just the latter? Okay.
No, so the first bit is in Python and exists within the Pydantic repo, and it was basically what we're working on now to complete to release v2, and then and effectively we're going through the like however many 5,000 unit tests of Pydantic v1 and making each of them pass one by one with the new system, and then the validation which is obviously the performance critical bit, that's all done in Rust, and is returning you the Python object that you wanted.
Got it. So is the aspect of Pydantic, which is about translating from Python type annotations into the core schema, is that changing at all from Pydantic 1 to 2, or is it mostly just this like validation serialization stuff that you're rewriting in Rust?
No, it's all rebuilt because we didn't have this concept of core schema of core schema in v1. So in v1 we built some ugly thing that was basically everything was around fields on a model, and that was all we had. And then we had these like validator functions, because as you can imagine, all the validation was in Python. So probably if you looked, for example, at the bool validator, which that's the right file. If you open that file, so this is the validator. So it's a Rust struct which defines how we're going to do validation of a bool, and in this case it only has one element, which is strict. So like I said earlier, deciding whether or not we're going to allow strings or numbers 0 and 1, or whether we're going to allow just the fundamental true and false values. So we build it as that first bit. In this case, building it's very simple, but as you can imagine, in some of the other validators, which are recursive, it's more complicated. And then further on down, we do validate, which effectively
validate bool.
So that is defined on we have, so it's defined but this abstract input is a trait, because the input in the previous case could either be a JSON value or a Python object, or a string to take care of the case of keys in JSON. So if you looked at the input, there's a Python input, which is an implementation of that input trait. So if you go up one level in the file hierarchy, I don't know if you can.
This?
Yeah, exactly that. And then if you look at input Python, that would then be the implementation of the input trait for a Python object. That'll just be quite near the top. So if you just scroll down a little bit more, you'll see input here for any pi, which is the like Py03 way of describing general Python object. We don't know anything about it. And then if you look at validate bool, or
Validate bool.
or what was it called? It was called lax bool or strict bool. It's not called that. It's called now you're challenging my exact memory of what things are called. But lax bool in that file or strict bool in that file. That's where we would then
strict bool.
Yeah. If we just search strict, there'll be lots of strict, but strict underscore bool.
Yeah, strict bool. Okay,
yeah. So you can see strict bool is very simple. We try to extract the raw value as a boolean, and we raise an error if not. Lax bool, we do some more complex stuff. So again, we look for it to be an actual bool, and then we convert it to, if that doesn't work, we convert it to a string and see whether it's a one of the allowed strings. If that doesn't work, we try extracting it as a I64 as an integer or as a float, and seeing if it's if it's exactly 0 or 1.
I see.
But cool. You would obviously the logic for bools would be relatively similar between Python and JSON, as I was saying earlier, but the logic for strict date time, for example, will be different between JSON and Python, where we know that there's no date time type, so we have to, even in strict mode, we have to allow a string for a date time.
Yep. That makes a lot of sense. Okay, this is very cool. I mean, all this code is just I mean, it feels very elegant, and it seems like a really neat use case of I guess like the Rust bindings into Python. Yeah. Sorry, go ahead.
And I've worked a fair bit with the guys from Py03. It's a very impressive project. But yeah, as you can imagine, Pydantic core has discovered a number of edge cases or bugs in Py03 just because of the like sheer depth that we go to.
Yeah.
So they've been really great working through problems with me, creating lots of issues.
That's awesome. Is anyone using the like not yet to be released version of Pydantic 2 as of yet? Like, is anyone kind of like trialing it, or is it still kind of in that not used?
I hope not for anything serious, because it will change a lot. But yeah, I mean, what I would say to people, if you're a heavy user of Pydantic, do go in and try, and like the sooner you come back to us with any problems, the quicker, the sooner it'll be fixed, or the more likely it'll be fixed before we release V2. So yeah, if you checked out or installed Pydantic directly from GitHub right now on main, you would get something that would work for basic validation. Some of the more advanced stuff like data classes, generics won't work yet because we're still working on it. Our JSON schema implementation isn't finished yet, but like the core of validation will work.
We had a question in the chat here on Twitch. What motivated you to make the default behavior coercion rather than throwing an error?
It's what I wanted. Like, in my opinion, if you submitted, so I made a decision early on to try and be lax like Python, to be Pythonic in that regard. So for example, if you pass a string of 1, 2, 3 to the int method, but also like built-in type in Python, it would convert it to the number 123, right? So I was trying to follow that example. Now that was a mistake in some regards. There are some crazy cases where that doesn't work. So for example, if you pass an iterable to the dict built-in type in Python, it will try and iterate over it, extracting pairs and create a dictionary. That's fine unless you pass in an empty list, or even an empty string is a valid input to a dictionary, because it just gives you an empty dictionary. That's obviously not what people want. So that was an issue someone was creating today. We had another case right early on in Pydantic where to check if something was a list, we just called the list built in on it. And if it passed, great. If it didn't, we failed. So that then meant if you had a list of integers and you passed it the string 123, it would first call list on it, split it up into 3 different characters, effectively 1, 2, and 3, and then it would call int on each of them. And so that was crazy and confused people. So we've moved to be a bit stricter over the years, but we're
Yep.
We're obviously taking the whole hog in V2 and providing strict mode, which is, obviously fully strict. The other thing to say is that people often think they want strict mode, but actually they don't. So I've talked about the JSON case where like there's no such thing as a path or a date time if you're in JSON, but like if you're parsing URL arguments, there's no such thing as an integer. So you're always going to have to pass an integer. And same thing with an environment variable, same thing with an input on a form, same thing with an input from a terminal. So there are lots and lots of cases where having that coercion just makes stuff work that people don't even realize about. Then some edge case comes back and bites them and they're like, why isn't it strict? But my suspicion is that when we have strict mode, loads of people will say, why isn't it strict? Hopefully they Google, find strict mode, switch it on and go, oh, turns out that's not what I wanted because everything now doesn't work because my input are all strings. But obviously you can set strict on an individual field. We still have functional validators where you can like cause an error if there's a particular behavior you don't want. So we still allow that full flexibility, but
I feel like from just a straight up user onboarding and user experience too, making it work even if there are these coercions just makes the onboarding experience more likely to reach that first like wow moment. Like someone uses your library, they run their code and they're like, holy crap, it works, rather than having to work through a bunch of strict type errors that all stand in the way of getting that point of value. So
exactly. So let's say you have a cookie token or cookie secret in your base settings, and that has to be bytes to be loaded into whatever library you're using, right? And then you want to set a special cookie secret in production on whatever tool you're using as an environment variable. If you if you were using a library that was strict by default, suddenly you would deploy and it would break because the input was a string, it needed to be a bytes, and they look exactly the same to a user, but they're obviously fundamentally different types. Pydantic would take care of that, be like, this field needs to be a bytes. I've got this string, I'll UTF encode it to bytes, and off we'll go.
Right. Okay, what about changes to the public API from Pydantic 1 to 2? Are you gonna make breaking changes, or is it gonna be fully backwards compatible?
I don't know if my camera is good enough for you to see the perspiration breaking out on my face with it. So we'll do our best to make the API as the transition as smooth as possible in terms of the API. We'll try and give nice warnings when you import something that doesn't exist, or try and access a method that no longer exists. The thing that's going to bite people, and I know it's going to bite people, and I know I'm going to have people angry about it, is fundamental changes to what we're prepared to validate, what we're prepared to coerce, and what we're not. And stuff like that, we can't. It's been a lot of work building Pydantic v2 on its own. If we build a compatibility mode where it was tried to behave exactly like Pydantic v1, it would have killed us. So that wasn't possible. We had to basically be like, we're going to do it right now, and obviously we're going to carry on supporting v1 for a reasonable time, but v2 has to happen. We have to make some changes. So for example, in v1, we would automatically coerce an int to a string. Because again, originally, because if you passed an int to the string method in Python, it would convert it to a string. So we did. I don't think that makes sense, really. But so the correct behavior is to give an error if you pass an int to a string. But that is going to break a bunch of people's code who didn't even know they were doing that. I don't think there's a way around that. We're obviously going to write a migration guide. What I've done before with minor releases is go and find the most popular libraries that are using Pydantic and literally do the migration for them to try and find errors. So I'll do a bunch of that, but I accept there are going to be a bunch of things that break, and I can't do that much about that. I'm very sorry, but I promise you that Pydantic v2 will be enough better to make it worth the pain.
What's an example? Is there an example of a thing that will break that you would want to find instances of out there in the wild? You mentioned the int coercion. Is there maybe we should just focus on that, or is there another kind of thing that's emblematic of something that might not be backwards compatible?
So for example, we will also the output from, so obviously I haven't talked about serialization, but we have serialization support for Pydantic models and for generally any data that we can validate. Again, we're doing the serialization. You can serialize to Python, which is effectively just turning models into dicts and otherwise not changing things. we can validate to, this is a new thing added in V2. We can validate to, sorry, we can serialize to JSON valid Python, which is a thing people want. So just the fundamental JSON types, but still a Python dict, list, string, etc. And then we can serialize directly to JSON. And again, in V2, that's all done in Rust and is pretty performant.
Interesting.
Our output type for that is going to be bytes, because the most efficient way of generating that JSON output is bytes. So we're going to change the output of the JSON method from string to bytes. That's going to break a bunch of people's code. Obviously, we're going to have the type annotations will be there, documentation will be correct. There'll be a migration guide, but that's going to break a bunch of people's code. What I don't know, there's the problem. I think really what I'm going to be looking for is things I don't know about. It's kind of the unknown unknowns are going to be the things I'm hunting for when I look at other people's libraries, or things where we can add value by basically either making it V2 compatible or giving a nice error, explaining a nice warning, explaining why stuff is invalid to try and help people.
I wonder if like we couldn't help you out with this potentially. So I don't know if you're up for this. I would love to. Like, is there like a regular expression or like some sort of pattern that kind of like matches a use of an API that is going to be kind of like backwards incompatible?
This is the first thing, Justin. Do you remember when I first got in touch with you? We were talking about my case then was actually trying to find the most common field types on Pydantic models in order to work out which ones we should optimize most. And that's how I first talked to you guys, and you very kindly sent me some data in one of your like notebooks that was helpful for that. Yes, there might well be, but I feel like I don't know what it is off the top of my head. So can I store up that very kind offer and come back to you sometime in the future?
Absolutely.
Yeah. I mean, I think from our perspective, it's just be a very useful point of feedback, because we want to make the query language as general as possible, but also like satisfy these kind of like power use cases where you want something specific. So like, if you wanted to express in the query language, like, I'm interested in, use of the, I don't know, what's an example of a field? So some field on the Pydantic, base model, show me all usages of that. And then ideally we could plug it into something like these pretty graphs where like we have a lot of customers that actually have this use case where they're tracking library deprecations. So if you want to track usage of a particular field, especially something that's going to be non-backwards compatible, we actually can like run that query and count the results at points in time. So you can actually see the pattern trend upwards or downwards and take appropriate action. And so we obviously want to make this work as generally as possible. And so I don't know, might be a fun like case study, provided that it aligns with the goals that you're trying to achieve.
Absolutely. Yeah. I guess I'll be in touch when we're a bit nearer the time, and that would be really useful.
Okay, cool. And we also have this thing, which is like large scale refactoring, which it's not quite enabled for open source yet. But the idea is that you can actually execute these large scale changes. So if you have some sort of like if you're doing a refactor for one project, let's say it's like a popular project, migrating them over from Pydantic 1 to Pydantic 2, and you write a script to automate part of that, because let's say the migration
that would be awesome, because we have some function names that are just changing. Like the most obvious stuff is we're changing the names of some of the methods on models so that it's harder to like clash with them. Having a way to be like, here's the batch script, here's the script you should run across your code that will fix the most common cases would be amazing.
Yeah. So like kind of the idea behind this is like, if you have like a large scale change campaign and you have like a script that kind of does the migration, you can actually go and like create draft pull requests for all the different projects that need updating. And it keeps you in the loop, so it doesn't create a bunch of like PR spam at one time. You can go and like individually inspect the changes and click a button to create the PR one by one if you want. But the idea is that it just like makes it possible to like manage this change across many different repositories, and then you have kind of like a nice like burn up chart, I guess, in this case, to see like how that campaign is going. So if that's of interest at all, like I don't know, it might be a fun kind of like collaboration.
Absolutely, that would be really cool.
Yeah. So what Samuel was referring to earlier, we had a notebook with a regex that would basically display a compute section in a notebook, but we relatively recently removed that functionality, so it doesn't show up anymore. But I dropped a link in the chat to show the regex that we were running.
Okay, cool.
Oh, nice. Thank you.
Awesome. Yeah, in kind of like the last 5 minutes here, like, is there anything that you're especially excited about upcoming for Pydantic around the release or otherwise?
Yeah, there's some exciting stuff coming up, but I can't make an announcement about that right now. So
Okay.
I will. The most exciting things I can't talk about, as is often the case. But we should have some announcements about Pydantic in the next few weeks.
Awesome.
And then the biggest thing I'm excited about is Pydantic v2, getting it released and seeing how people use it.
Yeah, awesome. Any questions from the audience? Please drop them in the chat. I guess final question. I think one thing.
I got a final question too, so
go for it.
Shoot. Okay, so with all this adoption, I'm sure there's a lot of issues and pull requests stacking up. What type of sustainability are you doing? Like, is there like an open collective or GitHub sponsors that you're collecting some money so you can, stay above water?
So there are two parts to that answer. Yes, we have GitHub sponsors, and if you're a user of Pydantic, I would love you to sponsor me. The other half of that solution, the answer to the other half of that is the thing I can't talk about. So some news will be coming soon. So follow me on Twitter and Pydantic on Twitter, and hopefully you guys will be kind enough to retweet when I have an announcement to make.
Absolutely, but I think does it have to do with the foundation? Just give me that.
I'm not going to
talk about it.
I gotcha.
I guess, like, do you have any like parting thoughts for other people watching who might be interested in contributing to Pydantic or just open source in general? Like, any general tips and tricks for creating a successful open source project or diving into an existing one?
I would love you to come and contribute to Pydantic. We, often me, try and be as friendly as possible. Obviously, we are, as with all open source developers and most people, overworked, and so occasionally are obviously a bit blunt. But we try and be friendly. More generally, I don't have any particularly clever words of wisdom. If I knew exactly why Pydantic was so popular, I would bottle it. But I still don't. Yeah, I'm not entirely clear why it was so widely used. Other than that, if you can avoid building your own of the fundamental inputs, that obviously lowers the onboarding curve, and I think that's what Pydantic has done really well. When we've been offered the choice between computer science correct and easy to get started with, we've chosen easy to get started with, and I think lots of people appreciate that. Parsing, automatically converting strings to ints. Lots of people will complain and say that's incorrect. It's awfully bloody useful in lots of situations. So I think that sometimes practicality beats purity.
Yeah, makes sense. Justin, maybe we can build an insight that can track imports of Pydantic over the period of time, from 2020 to now, to see where the inflection point happened, and then that's something worth exploring.
If you could find out why, that would be absolutely fascinating. Something happened. I don't know if it was adoption by a big company, but and obviously lots of it will be closed source, but something weird happened.
Awesome.
Back in 2020.
We will get our investigative team on this. Channel 9 investigates.
We'll put our code archaeology hats on.
Yes,
I think that's something we specialize in. So.
Wait. We got a question.
Oh.
Fast API happened that also used Pydantic heavily?
Oh yeah, he's saying that Fast API might have contributed to the
Oh, got
inflection
it, got it,
point.
got it,
Yeah,
got
it
it.
definitely did. But I think what you were saying, Samuel, is that there was a lag between when they started using it and when you kind of saw the bump in downloads start to
Yeah,
happen.
and while Pydantic's growth has been crazy, there isn't like an inflection point within Pydantic as well. If
Yeah.
I don't know if you have time just to show that graph again, but like yeah,
Oh yeah, yeah.
I didn't see a particular. There wasn't like I'm sure that lots of people heard about it through Pydantic because Sebastian's documentation is incredible. Like the whole thing is amazing, but like you can see Fast API, which is the whatever it is, light blue line there.
Yep.
It doesn't show the same like tick up. Then it's a much more like smooth exponential
Yep.
growth for Fast API.
Yep. Awesome. Yeah, the kind of purple red line here is Django. Blue line is or the teal line is Fast API here.
Yeah.
And then Pydantic is just a rocket ship.
So you do see an uptick in usage of Pydantic when Fast API was released, whenever it was, but like on this graph, it's indistinguishable. It's down there, like yeah, it's there, or like
we
in 2018.
We do this on a log scale.
Yeah.
Yeah.
Awesome. Well, Samuel, thanks so much for coming on the stream today. This was awesome, super interesting. Congrats on all the progress, and I look forward to the upcoming news that you can't talk about. That's very intriguing.
No problem.
Exciting.
Yeah.
Maybe I
it's gonna
can
be
come
fun.
back and speak to you again later in the year when I can talk, when we've got V2 released and when I
Dude,
can talk about that stuff.
Samuel,
let's do
you
it
have
again.
an open invitation. We only say that to a select few.
Awesome. Well, great to meet you guys, and thank you very much.
All right. This
Likewise.
is awesome.
Thanks,
Everyone for joining
everyone.
on the stream. Take care.
All right.
Awesome.
Cool.
That was awesome. Thanks so much
Yeah.
for doing this.
It was I didn't realize you had that spike. Like I knew Pydantic was doing good, but wow.
I didn't know either until I was I produced this graph and was like, wow.
Yeah, no, that's great. I would recommend getting on Open Collective, because then companies that already are on Open Collective can donate to you, like us and a few others. So just a recommendation.
That's cool. I have actually got an account on Open Collective because Salesforce gave me $10,000 last year and they asked me to sign up, but I don't know if I'm like public on it. Am I right in thinking you guys, who was it? There was one, was it thanks.dev?
Yeah.
Where I think I got some money from you guys, like a few £100. So thank you if that was you. I think it was. I'm trying to remember. I haven't like.
Yeah, we
with
have a
thanks.dev.
thanks.dev account. So if we're using you in our stack, then we automatically pay you. But yeah, Ollie's a good guy. Good project.
Yeah, cool. Well, thank you very much. I'll let you guys go.
Likewise. All right,
yeah,
man.
thanks, Samuel.
Have a great
Talk
day.
soon. Cheers.
You too. Cheers. Bye-bye.
Bye.